In this session, we are going to discuss the classes and objects. Before that, let's start with structures in C programming. So what is the purpose of structures in C programming language? One thing is you can group different types of data under a single name. Another thing is the structures are used to create user-defined data types. Struct by using keyword called struct. Struct followed by student. Okay, this is the way how you are supposed to define structures in C programming language. Generally, in C programming language, we use structures to create our own data types, to create our customized data type as per our convenience. In this student data type, you can group all the information related to a student. What are the properties a student can have? A student can have student ID, name. C programming language, you can use the character as first. Okay, then student fees, how much fee a student is currently paying. What is the department of a student? Department, section of a student. So these are some of the properties of a student. So here what we are doing is, here we are creating a new data type called student, which contains all these properties. So this is the way how you are supposed to create a new data type in C programming language. And this is also called as creating a blueprint. So it's a blueprint. So once you create a blueprint, by using this blueprint, you can create any number of copies of students with the help of something called as structure variables. Struct student S1, S2, S3. Here, S1 is a variable of student type, S2 is a variable of student type, and S3 is a variable of student type. Here, S1, S2, and S3, these three variables are copies of a student. Okay, S1 contains all these properties, S2 contains all these properties, and S3 also contains all these properties. So assume that this is a student one. This student will have the properties like ID, section, fees, name, department, percentage. Okay, this S1 is an object. S1 object contains all these properties. Okay, as S1 is a copy of student type, S1 contains all the properties of a student. What S2 contains? S2 is also a copy of student type. S2 will also have a copy of student type. And the same way, S3 also will have a copy of all the properties of student type. So here what I am doing is, initially I am creating a new data type. Initially I am creating a new blueprint. So once I create a blueprint, from that blueprint I can create any number of copies. S1, S2, S3 and so on. You can create any number of copies. And the advantage is, you need not to declare all these variables separately for each copy. You need not to declare them for S1 separately, S2 separately, S3 separately. First, create a data type, create a blueprint. From that blueprint, you can create any number of copies. Each copy contains all the properties of a student. This is what happens with structures in C programming language. So if you want to access the members separately, then you can make use of an operator called as a member access operator called dot operator. You can access them. For example, if you want to access ID of a student 1, S1 dot ID. If you want to access the ID of second student, S2 dot ID. If you want to access the ID of third student, S3 dot ID. So you can differentiate all those properties across the objects with the name of this variable S1, S2, and S3. The same thing that you can, the same thing what you have done as structures in C programming language, you can do the same thing in Java also. Okay, you can create new data type, you can create a new blueprint. Here, instead of using a keyword called struct, you can use a keyword called as class. That's it. And here you need not to use a semicolon for classes in Java. In C programming language, we are calling this as structures. In Java programming language, we are calling this as the classes. So by using classes, what you can do is you can create a new data type, or you can create a blueprint. Once you create a blueprint, then you can create any number of copies of that blueprint. Now let's see how to create copies, and those copies are called as objects. Okay, you can create a copy of the student type like this. The class name followed by a reference variable is equal to new student. This is the way how you are supposed to create copies of student type. Okay, this is the way how you are supposed to create copies. These copies are called as objects. This new keyword will allocate memory for an object of student type. If you do like this, new int, it will create memory for integers. Okay, the new keyword is for allocating memory dynamically, or also called as runtime. Here what happening is, a new keyword will create an object of student type, and that object will be referred by a reference variable called S1. Here S1 is a reference variable. Here S1 is a reference variable, and this S1 variable is refers an object of student type. If you want to create one more object, you can do like this. Student S2 is equal to new student. So here S2 is a reference variable. And if you want to create one more object, you can do like this. S3 is equal to new student. So this is the way how you can create objects for the class which you like. Here what you are doing, by using new keyword, you are creating an object, and that object is referred by a reference variable S1. Here you are creating another object, and that object is referred by S2. Here you are creating one more object, that object is referred by S3. Here S1, S2 and S3 are called as reference variables. See here, copy of student type S1, a copy of student type S2, a copy of student type S3. So this is the way how you are supposed to create your blueprint or your data type in Java. Once you created your blueprint or data type, you can create any number of copies. Same like C programming, here also, if you want to access individual members, and you can access the same way, s1.id, s2.id, s3.id, okay. S1.fees, s2.fees. So you can access individual members with the help of reference variable S1, S2, S3. Here we are calling this as a structure variables. Here we are calling this as a reference variable. Each reference variable is referring to an object. In C programming language, you can only have the properties. You can group only the properties for data type. You can group only the properties. But in Java, along with the properties, you can also group behaviors also. Okay, in Java, you can even add behaviors for your classes. A student can read is one action, one behavior. A student can write. A student can eat. A student can play. Okay, these are the behaviors of a student. So this is one variation when you compare structures in C programming with Java. In Java, apart from the properties, you can also group behaviors also. Let's create one more data type, car data type. Class car. What are the properties a car can have generally? Mileage, cost, color, type of the car, brand. So these are some of the properties of a car, right? These are some of the properties. A car can have some behaviors. Those behaviors are nothing but what you can do with a car. You can move forward, right? You can move forward by travel, move backward. What else? You can start a car. You can stop a car. Apply gear is an operation. Apply gear is an operation. This is the way how you are supposed to create your data type in Java. Okay, whatever the data type you would like to create, okay, create like this by adding the properties and actions. These are called as properties and these are called as behaviors. So these are also called as data members. These are also called as data members, and these behaviors are called as member functions. So from here onwards, I'm going to use these two words: data members and member functions. Data members are nothing but the properties, and member functions are nothing but the actions, the behaviors of that particular data type. So this is the one major difference between blueprint or data type between C and Java. In C programming language, you can have only properties, whereas in Java programming language, apart from the properties, you can have even a behaviors also. These are called as instance variables. I'll tell you the difference between instance variables, class variables, and local variables. Static int number of cars. Assume that play is a function. Let's write some code in the play function. Now the question is, we have three different types of variables here. This is one category of variables, and there is one more category of variables with a keyword called static, and there is another kind of variables here. Okay, there is a concept called as instance variable, static variable, and local variables. Out of these three categories, which variable is a local variables? Which variables are local variables? The variables which are defined inside a method is called as local variables. The scope is limited to this block only. After this block, you cannot access variable X. This is a local variable. These variables are called as instance variables. When I say instance variables, these are variables for every object. Okay, whenever you create an object, every object will have a copy of these instance variables. S1 is having a copy of instance variable, S2 is having a copy of instance variables, and S3 is having a copy of instance variables. But here, the number of cars is let's say number of students. This variable is called as class variable. In the sense, these variables will not be there for each object separately. Each and every object will not have a separate copy of this variable. This variable belongs to a class. Okay, if you want to access this variable, you have to access only by using a class name like this: student dot number of students. Okay, this variable belongs to a class, and a copy of this variable will not be created for each and every individual object. If you make any variable as a static inside a class but outside the method, that variable becomes a class variable. That class variable is not belongs to any object, it belongs to a class. And if you want to access that variable, you can access only by using class name, not by using the object. So these are the instance variables. Each object will have a separate copy of this. This is a class variable which defined using a keyword called static keyword. And these variables are not belongs to any objects. This belongs to a class. And these are the local variables, variables which you declared inside a method. And instance variables and static variables, generally we will declare inside a class but outside a method. Okay, instance variables and class variables you have to declare inside a class but outside the methods.